The ACT is right around the corner. So here are 5 practice problems to help you prepare for the exam. So here's the first problem that we'll be doing in this video. It says if b is equal to -3, what is the value of 4b squared minus 2? Now, when it says to find the value of something, we're just looking for a number. And the only thing that's stopping us from finding what number this is equal to is the letter b, because we can't really do math with letters, right? But we know that b is equal to -3. So how about we just plug in -3 for b and then solve it? So I'm going to rewrite 4b squared minus 2, but instead of b, I'm going to write -3. And I'm putting it in parentheses so that we don't get confused over it being like subtraction or anything. Now we just need to simplify this. And to find out which step to do first, we're going to need to use PEMDAS, the order of operations. So the P in PEMDAS stands for parentheses, but the only thing in parentheses is this -3 just by itself. So we can't really do anything with that. So let's move on to E, which is exponents. And I see here we have -3 to the power of 2. So that's -3 multiplied by itself. -3 times -3 is, well, 3 times 3 is 9, and then 2 negatives make a positive. So -3 squared is +9. So instead of -3 squared, I'm going to replace it with 9. And now the next step is multiplication and division. And here we have multiplication. Whenever you don't see a sign in between things, that means multiplication. So 4 times 9 is 36. And then all that's left is, well, the addition and subtraction, but we only have one thing left here. 36 minus 2 is 34. So there we go. We've found the value of 4b squared minus 2. It's 34. All right, here's the first word problem of this video. There's going to be a lot of those on the ACT. So it says for a certain cleaning product, the ratio of solution to water is 1 to 12. How many cups of solution should be added to 3 gallons of water? So basically, we need to have a certain amount of solution, which, just like cleaning solution, and then a certain amount of water. Now, it says there are 3 gallons of water, but we have to figure out the amount of solution in cups. So that's an important thing to know for these problems. You need to know what your units are. And then it says that the ratio of solution to water is 1 to 12. So basically, for every 1 cup of solution you have, you're going to have 12 cups of water. So for example, if you had 24 cups of water, then if you wanted to find out how much solution there is, well, we could just divide by 12, and 24 divided by 12 is 2. So then 24 cups of water means 2 cups of solution. So we could just do that with this, but there's one problem, and that is that this is in gallons. So for this to make any sense, we need to switch the 3 gallons into cups. So it gives us a little hint here. It says that 16 cups is equal to a gallon. So how do we find out how many cups are in 3 gallons? Well, we can just multiply it by 16. So if you put this in your calculator, 3 times 16 is 48. So 3 gallons is equal to 48 cups. So now we can use our ratio, which is 1 to 12. 1 cup of solution, 12 cups of water. So we'll just do what we were talking about before. We'll take our 48 cups and we'll divide it by 12. So 48 divided by 12 is 4. So our final answer is that there are 4 cups of solution for 3 gallons of water. Okay, here's our third problem. It says Bob sells 3 flavors of ice cream. Yesterday, half of the scoops sold were vanilla, a fourth of them were chocolate, and 7 were strawberry. How many total scoops did Bob sell? So where do we start with this? Well, the way that I think we should start is we should figure out what fraction 7 is. What fraction is strawberry? And remember that the fractions should all add up to 1, to 100%. So 1/2 of the scoops sold were vanilla, and 1/4 were chocolate. So what's left over for strawberry? Well, let's start with 1, right? 1 is the total of all the fractions. And then 1/2 is being taken up by vanilla. And then 1/4 is being taken up by chocolate. So what's left for strawberry? Well, let's go ahead and convert these fractions into numbers that we can work with. So remember that if a number's not a fraction, it's just over 1. And we can get these as a common denominator. I'm going to try to get them all as a denominator of 4. So to get the bottom numbers all to be 4, let's multiply this fraction by 4 over 4. Because remember, as long as you multiply it by the same number, top and bottom, then it's fine. So 4 times 1 is 4, and 4 times 1 is 4. So 4 over 4. And now 1/2, this is already a 2. So to make this a 4, we just need to multiply it by 2. So 1 times 2 is 2, and 2 times 2 is 4. So 1/2 becomes 2 over 4. And 1/4 already has 4 on the bottom, so I'm going to keep it the same. And now because these are all in fourths, we can do our subtraction. So we have 4/4. We're subtracting 2/4, so that's just 2/4 left. And then minus another fourth, so we only have 1/4 left. 4 minus 2 minus 1. So this means that 1/4 of the ice cream that was sold was strawberry. And we also know that 7 scoops sold were strawberry. So I think this will make more sense if we think about it visually. So here are all the scoops sold, right? This is the total sales for the day. And because this is in fourths, let's go ahead and divide it into fourths. Now here are the strawberry sales, right? And 7 scoops were sold, and they make up 1/4 of the total sales. Now remember that we don't need to figure out how much vanilla and how much chocolate was sold. We just need to figure out the total amount. So let's just think about this, right? If 1/4 is 7, then that means this quarter is 7, this is 7, and this is 7. So to find the total sales, let's just add these up. 7 plus 7 is 14, plus 7 is 21, plus 7 is 28. So if you add these together, there were 28 total scoops sold. So sometimes you don't even actually have to write out a math equation. You just have to think about it logically, think about it visually, maybe even draw something like this if it makes sense to you. And there we go. We've come up with our final answer, 28 scoops. So here's a probability problem. It says that Mr. Person flips a coin and rolls a 6-sided die. So he's doing 2 different things. He's flipping a coin and rolling a die. So what is the probability that he flips heads and rolls a number less than 5? So he's doing 2 actions, right? We need 2 things to happen. We need him to flip a coin, and this coin needs to land heads. And he's also rolling a die. And this die needs to land on a number that is less than 5. So let's figure out what the probability is of each of these things happening by themselves. And then we can combine them to figure out the probability of both of them happening at the same time. So first of all, what is the probability of a coin landing on heads? Well, probability is always the number of ways you could do it successfully over the total amount of possibilities. So a coin only has 2 choices, right? It's either heads or tails. And how many of those 2 choices would be a success? Well, only one of them, because if he flips heads, then it's a success, or if he flips tails, then it's not a success. So the probability of flipping heads is 1/2. Now, what about the die? This might be a little more complicated. It needs to roll less than 5. So how many different possibilities are there for a die? Well, you can roll a 1, 2, 3, 4, 5, or 6. So there are 6 different possibilities. But it's not going to be 1/6. Out of those 6 possibilities, how many of them would be a success? Well, it's any number that's less than 5. So that would be 1, or 2, or 3, or 4. It wouldn't be 5 or 6, because neither of those are less than 5. So there are 4 possibilities for success out of the 6 different numbers that we can roll. So our probability is going to be 4/6. Now we could go ahead and simplify this fraction, but I'm actually going to do the combination first and then just simplify the fraction. So we have our 2 probabilities now. So how do we combine them? Combine the chances of both of them happening? Well, you might think that, oh, well, to combine them, we'll just need to add them together, right? 1/2 plus 4/6. But that actually doesn't make sense because when you add them together, you're increasing the chances. And the chances of 2 things happening at once seems like it would make it harder. So to find the chances of 2 things happening, we actually have to multiply the probabilities. So we're going to take 1/2 times 4/6. And remember that to multiply fractions, you multiply the tops and you multiply the bottoms. So 1 times 4 is 4, and 2 times 6 is 12. So the probability is 4/12. Now, before you just go ahead and accept this answer, we need to ask ourselves if we can simplify the fraction. And if you were doing a multiple choice problem, for example, this probably wouldn't be an option to pick. So how do we simplify this? Well, it looks like both of these can actually be divided by 4. So if we divide both the tops and bottoms by 4, 4 divided by 4 is 1, and 12 divided by 4 is 3. Which means that our simplified fraction and our final answer is 1/3. So basically, if you were to flip a coin and roll a die, then the chances of both of these happening at the same time is 1/3. And that makes sense. It's a little bit less than the 1/2 for flipping the coin. Now here's a geometry related problem. It says, what is the diameter of a circle with an area of 50.24? Now here's the little bummer about the ACT math section. If you've ever taken the SAT, you may know that it gives you a formula sheet that you can use for geometry problems. But most of the time the ACT is not going to give you any formulas. You'll have to know them already. The good news is that a lot of these formulas are actually pretty short. Like for example, the area of a rectangle is length times width. But here's an important formula to know, and that is the area of a circle. And I know that even though we're solving for diameter, I'm probably going to use the area of a circle formula because it gives us the area. The area of a circle is pi times the radius squared. Now you may be asking yourself, well, we're trying to find the diameter, right? So why are we doing a formula with radius? But remember that for a circle, just pretend that this is a perfect circle, the radius is basically the distance from the middle to like the side of the circle. So that's the radius. But the diameter is all the way across. So the diameter is basically just two radiuses. So if we found out what the radius is, we could just multiply it by 2 or add it to itself and figure out the diameter. So let's go ahead and plug in what we know for each letter. This is how you use formulas. You just plug in every number that you know. So A, we're going to replace with 50.24 because we know that that's the area. Now pi is always 3.14. So depending on the problem, you might have to replace pi with 3.14, or you leave pi the same and just treat it as if it's like a variable. So if you're not sure which one you're supposed to do, then look at the different answer choices for the problem. And if they all have pi in it, then I would just leave pi the same. But if they're all just numbers, then you can replace pi with 3.14, which is what I'll do for this problem. And now r, I'm going to leave as r because that's what we're trying to figure out. That's what we're solving for. And r is going to be squared. So let's just go ahead and solve this algebra problem. We need to get r by itself on one side of the equation. And basically we're doing like reverse PEMDAS. So we have an exponent here. That's pretty early in PEMDAS. So I'm going to do that last. I'm actually going to get rid of this 3.14 first. And remember that this is multiplication when there's a number and a letter next to each other. So I'm going to do the opposite of multiplication, which is division, and divide both sides by 3.14. So these cancel out. On the right side, we just have r squared. And on the left side, we have 50.24 divided by 3.14. So if we just go ahead and put this in our calculator, we should get 16. So r squared is equal to 16. The last step now to solve for r is to get rid of this squared. And the opposite of squaring is square rooting. So I'm going to square root both sides of the equation. So the square root and the squared cancel. On the right side, we just have r. And on the left side, we have the square root of 16. That's what number do you have to multiply twice to get 16? Well, 4 times 4 is 16. So the square root of 16 is 4. Now, technically, when you're square rooting both sides of an equation, you're actually plus or minus square rooting. So this would be plus or minus 4. But the lengths of lines are not going to be negative. So we're just going to use the positive answer of 4. So our radius of the circle is equal to 4. But always remember what the question was asking. It was asking for the diameter of the circle. So how do we find the diameter? Well, let's go back to our circle diagram from before, our perfect circle. And our circle is going to have a radius of 4 something, centimeters, inches, or whatever, I don't know. But we're looking for the diameter, which is all the way across. Well, that's just going to be another radius, and that radius is also going to be 4. So let's just add these together. 4 plus 4 is equal to 8. Which means that the length of our diameter is 8, and that is our final answer. So those were 5 important concepts that you'll need to know for the ACT math section. But obviously that was not everything that you'll need to know for the exam, and there are a lot more concepts that I wasn't able to cover in this video. So if you're ready to keep studying, then this is the video that you'll want to watch next. And as always, if you have any questions about this video, go ahead and leave a comment and I'll be sure to answer your question. Thanks for watching and good luck on the ACT.